In chapter 7, we are going to go back and talk about sampling distributions where we are talking about z-scores. So we're going to go back to the normal distribution, which we talked about earlier. So to review, a continuous random variable is a variable that can take on any value within a specified domain. Every interval within the domain has a probability associated with it. So a continuous random variable with a normal distribution is commonly used to describe populations. The distribution of a normal random variable can be described by a normal or bell-shaped curve. So the area under a normal curve over a given interval represents the probability that a particular value lies in that interval. So there's 3 common different intervals that we use. So we have that the probability of our variable x can be less than a specific variable. So if this is our sum variable we're looking at, less than would be below it. We could be between 2 values. Or we can be greater than a specific value. So when we're solving probability problems using normal random variables, we're going to start to include things because we're going to build upon this in later sections and chapters. So it's important we include a few things. So the first thing we're going to do is talk about, we're going to state the distribution and the values of interest. So what that basically means is we're going to state the probability we're trying to find. We are going to make sure we show all of our work when we're performing our calculations, and then lastly we're going to answer the question. So let's start with an example. So the heights of young women closely follow the normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. So this is a distribution for a large set of data. Now choose one woman at random. So we want to know what's the probability that the chosen woman is greater than 65 inches tall. So we're trying to find the probability that x is greater than 65. So we're going to draw our distribution. We place our mean, which is 64, and then the value we're trying to find. So what we want to do when we're showing our work is we want to make sure we're talking about what we're using in the calculator. So we're going to be using normal CDF. So we want our lower bound to be 65, our upper bound to be our 9s. We're going to plug in our mean of 64 and our standard deviation of 2.7. And we're going to get a probability of 0.3556. And we are going to want to make sure we round 4 decimal places here. So what if we want to know the probability that the chosen woman is less than 63 inches tall? So that's the probability x is less than 63. So drawing our curve, we have our mean of 64, and then 63, and we want to be below it. So again, we're going to do normal CDF. This time our lower bound is going to be -9s because we're doing less than. Our upper is going to be our value of 63. And we're going to use our mean of 64 and our standard deviation of 2.7. And we're going to get that our probability is, again, 0.3556. Which makes sense if you think about it, because both of the values we looked at, 63 and 65, are both one standard deviation away from our mean of 64. So it makes sense that they would have the same probability above and below that value. And then lastly, we want to find the probability that a woman is between 68 and 70 inches tall. So we're doing the probability between 68 and 70. Do our mean 64. And their values 68 and 70, and we're finding the probability we're between those. So when we do probability between, it doesn't necessarily have to be, our mean doesn't have to necessarily fall within that range. So our lower bound is going to be 68. Our upper bound is going to be 70. We're going to do our mean of 64 and our standard deviation of 2.7. And we are going to get a probability of 0.0561. So what we've covered up till now has been review. So now we're going to expand on that by combining normal random variables. So our first example, Mrs. Goldschmidt likes sugar in her coffee. From experience, she needs between 8.5 and 9 grams of sugar in her coffee to make the drink taste just right. While making her coffee this morning, she added 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. What is the probability that Mrs. Goldschmidt's coffee tastes just right? So first, the probability we're trying to find is that she has between 8.5 and 9 grams of sugar. Now, we can't just use the mean and standard deviation that we're given because that's for one packet of sweetener. And if we look, she added 4. So we need to recalculate our mean by taking the number of packets of sugar and multiplying it by 2.17. Because each packet of sugar has the same average amount of grams in it. So we get a new mean of 8.68. We also need to recalculate our standard deviation. So the way we do that is we take the square root and we take our standard deviation, we multiply it by 4, and we square it. So we're going to do 4 times 0.08 squared, and then we're going to take the square root of that number. And we're going to get a new standard deviation of 0.16. So now we have our new mean, 8.68, and we're looking to be between 8.5 and 9. So we're going to use normal CDF. We're going to have a lower value of 8.5 an upper of 9, our mean of 8.68, and our standard deviation of 0.16. And we're going to get a probability of 0.847. So the probability that Mrs. Goldschmidt's coffee tastes just right is 0.847, which is pretty good. So the last thing we have is that the diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inches. For a lid to fit on a cup, the value L has to be bigger than the value of C, but not by more than 0.06 inches. What is the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? So we're going to define a new value, F, which represents the lid fitting, where we take the standard deviation of the lid minus the size of the lid minus the size of the cup. But that difference can't be between more than 0.06 inches. So what that means is we're finding the probability that the difference has to be somewhere between 0 and 0.06. Because it could fit exactly, but it can't go more than 0.06. Okay? So what we need to do is we need to find our mean of F and our standard deviation. So our mean is we're going to take the means of our two values and subtract them. So we're going to take 3.98 minus 3.96. So we have a new mean of 0.02 inches. We also need to calculate our standard deviation. So we're going to do the square root of the difference of our standard deviations squared. So we're going to take 0.02 squared minus 0.01 squared. Sorry, I said difference, but it does need to be addition. Sorry, not subtract them. We're going to add them. So 0.02 squared plus 0.01 squared, and then we take the square root, and we get a new standard deviation of 0.0224. So what we can do now is draw our distribution. So we have our new mean, 0.02, and we need to be between 0 and 0.06. So we're going to do normal CDF. Our lower is going to be 0. Our upper is going to be 0.06. We have a mean of 0.02 and a standard deviation of 0.0224. And we get the probability is 0.776, well, 7, because it's a 0.77696, which becomes 0.777. So there is the probability that a lid will fit a drink cup is about 0.777. Please let me know if you have any questions over anything from either the review part or the expanded part with these last two examples.